So in this video I'm going to try to give you some examples of two different types of values that we're going to want to keep track of in physics. I have open here a simulation that shows, or that simulates what happens when you've got a mass and you hang it from a spring. If you want to play with this simulation yourself, you can type PHET FET spring or springs into a Google search and it'll be the first thing that comes up. But most I just want to show you that there are a few different examples here of things that we might want to measure in a physics classroom. There's this thing that I'm holding right now is a mass. You might be able to read that it says 250 grams. We could measure that maybe by putting it on a balance of some kind. I've got some other things here that we could measure, like time. I can measure with a stopwatch. It looked like there was 1.78 seconds between when I hit the start button and when I stopped it again. Another thing here that we can measure or put a number to is the thickness or the softness, this is called, of this spring here, spring number 3. I can make it thicker and thinner, and you'll see, incidentally, that if I hang a mass from a thin spring, it hangs much less far down than if I hang it from a thin spring. Anyway, you can play around with this simulation if you want, but the mass, the time, and the spring thickness are all things that I'm offering as examples of things that we might want to measure or put a number to in physics class. Another type of number or value that we might want to measure in physics class is illustrated by another simulation. You can find this one by typing in PHET again and then the word vector, which is VECTOR. This will be the first thing that comes up here. But the thing that's probably striking, I hope, that's different about this type of, or this value that I'm representing here with this arrow, is that it has a number associated that is like the length of the arrow can be, in this case it's 28.3 length units long, or it can be say 25, or if I move it down here it can be just 20 length units. That is, we can put a number to the length of this arrow just like we could put a number to the time or the mass, but there's something else about the arrow that makes it unique. That is, if I make another, well, sorry, let's make this a length of 25. If I make another length 25 arrow, it's not exactly the same as this other arrow, because there's something else about it that makes the arrow unique, or that like characterizes that particular arrow, which is the way the arrow is pointing. That is, not just that the arrowhead is on this side rather than this side, but that this particular arrow is pointing a little bit up and a little bit to the right, whereas this arrow is pointing entirely to the left. The direction of this arrow is important in the same way that the length of the arrow is important. So in physics, things where the direction of the value is important are referred to as vectors, V-E-C-T-O-R, whereas things like mass or time or spring thickness, where there is no real direction, are referred to as scalars, S-C-A-L-A-R, is how you spell scalar. That is, if we think about this mass, we can't think about it as 100 grams to the right or 100 grams up. We can't think about this spring thickness as, like, I don't know, like, we don't have units for spring thickness now, but it's not a thick spring up, it's just a thick spring. Whereas this 25 length arrow is 25 length units in a specific direction. Now, it's not entirely pointing in one direction. I'll have to say this for another video, but we can express the direction of the vector as a combination of two different vectors. That is like how much up it's pointing and how much to the right it's pointing, or in this case, say how much to the left and how much down. These are referred to as components. These pink arrows here, and they're useful for describing vectors. But essentially, the crucial difference about a vector is that it has information about direction. I want to leave you with a question. I didn't mention this measurement tool over here, this ruler, because it's a little tricky, I think, to think about whether this ruler is measuring a scalar quantity or a vector quantity. That is, like, whether something you measure with a ruler has direction. In this case, if I measure, say, how far the mass hangs when it's hanging from this spring, I could measure that it looks like it hangs like, I don't know, 9 length units down. And the fact that it was important that the mass hung down seems to imply that that would have direction. Although if I measure something else, that is like the length of this spring right here, which looks to be like 28 length units, if I put the spring on its side, I would still find that it measured a length of 28 length units. It is like the direction of the length of the spring isn't important here. So I'm going to leave you with that as a question, whether things we measure with a ruler should be called a scalar or a vector. But you already have some examples of of scalar quantities in time and mass and spring thickness, and vector quantities in these arrows here. Now these arrows can be used to represent other values like the velocity of an object or the force on an object, but we're going to have to leave those for another video as well.